We're going to be talking about triangles with something new. We're going to be talking about them with what's something new called medians. You might have heard of altitudes, but they'll be new for this lesson also. We're at 5.3. We only have 5.4 after that, and then there's a review and test. So this week we'll have 4 things for you to do. 2 lessons, a review and a test. So there will be, you'll have a test very soon. We had a test last week and a test this next one also. All right, let's get started. All right, you have a definition of a median in your book there. I've drawn a median up here, and I'm going to read the definition of a median. It's in your postulate books. I let you write definitions this time in your postulate books. So if you want to get that out, and if you want to, I'll show you what you're supposed to do to draw this, but let's at least read the definition of a median. A median is a segment from a vertex to the midpoint of the opposite side. So I want you to notice that this segment that I've drawn up here, that segment AB, no, excuse me, not AB. I'm going to actually name it. I don't know, I'll name it D down here because it just seems logical. That's the next letter. Notice that this thing right here does not go perpendicular. It's not perpendicular. Based on this definition up here, it says it's a segment that goes from the vertex to the midpoint of the opposite side. And so, what do we know about this segment down here?
BD is congruent to DC?
Yes. So BD is congruent to CD because it's the midpoint. All right, I'm going to let you draw that and give you a chance. I've actually put the marks in there also. BD is congruent to DC. Okay. There are going to be multiple midpoints that we can draw. We can have a midpoint. If I put a midpoint right over here, I'm going to just estimate it right now. I'm going to put a midpoint, let's right here, right there, so that these two are congruent. So the median would look like this. Okay, so far so good. If I did the midpoint about right there, so that this one's congruent to that one, they will connect. They're concurrent, and that's really cool. Another concurrent thing. That point of concurrency is called the centroid. Okay, I'm going to spell that out for you. You have
just put the postulate in our book.
That's correct. So if you want to use this same picture that you just drew in your postulate book, you have this centroid. Don't you have the word centroid of a triangle? And so you could.
Centroid theorem.
Then you'll have a centroid theorem too. So your centroid of a triangle, if you'd like to just now put an arrow and put 3 medians in there, they're going to be.
Is that what the centroid of a triangle is?
Yes, they will. It'll be all 3 midpoints. Excuse me, all 3 medians. They are concurrent. Your centroids should be concurrent. The next slide will be talking about where they're concurrent at, but they're all concurrent.
Okay, just a minute.
You could just, from that centroid of a triangle theorem that you, no, not theorem, the centroid of a triangle definition, you could just put an arrow over there, okay? Here's the next one. Now that we know about the centroid, I have pictures of 3 different kind of triangles. I have an acute triangle here, an acute triangle, and it's got 3 medians there. I've got an obtuse triangle and 3 medians with a centroid, and a right triangle. When you were doing your orthocenters and your circumcenters, some of them, when they would meet at their point of concurrency, they weren't always inside the triangle. Sometimes they were kind of weird and outside the triangle. I'm trying to remember it more like the.
Are you referring to those sketch thingies I couldn't figure out how to do?
Yes, and so we'll do those with you. Yes, later. I think it was mostly
It was always the obtuse.
the obtuse ones for the both circumcenter and I think probably just the in-center one. The middle might have been.
I thought they were both out.
We'll have to look.
It was twice on my homework.
Yeah,
Okay.
I had it happen twice. I just
And
don't
it was
remember.
out, and it was supposed to be inside, and I don't understand.
Okay, so we'll go over those because she needed help too. So
Yeah, I looked it up and one of them was out.
so sometimes those centers, whether I think it was either the incenter or circumcenter, maybe both. Sometimes they're in the circle, sometimes they're out of the circle. I'm going to tell you right now that your centroid will always be inside the circle. All right? Your
Triangle.
Excuse me. Triangle. Thank you. Your centroid will always be inside. All right?
Ooh, that's a difference.
I can't tell you if it's a relief because I can't figure
All
it
right.
out.
Your centroid theorem. Your centroid theorem, it's in your postulate book already. We're going to do something with it. The centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Let's look at a picture so you can see what that means. Here is the place where the centroid is. Okay? It's going to show you these little, it's got a little like animation-like thing. It's showing you now. I'm going to stop there. Okay? I want you to notice that it's a little bit bigger. Do you see it looks green on my screen, but it's right there. It stops there. You've got the whole thing, and then you've got that piece there. Okay? From of the vertex to the centroid is 2/3 of the whole. If that distance is 2/3, how much is that one?
1/3.
1/3. Okay? Because 1/3 plus 2/3 is a whole. All right? So, if you knew the distance of the whole thing, you multiply by 2/3 and you'd have this length right there. Okay?
Or if you knew the distance of the half, then
If you knew, another thing, if you knew the distance to right here, how would you find the distance right there?
multiply by 0.33.
No? How much bigger is the yellow part than the red part that I have left? How much bigger is this compared to that? 2/3 or 1/3?
2 times.
2 times more. So if you knew that one,
You would divide it by 2.
divide it by 2 to get that one. Okay, so let's do it. Let me do some numbers so we can figure that out. Okay, so if this part right here, I'm going to make it in yellow, is, let's say, 6. How much would that piece be?
3.
3. How much would the whole be? How much would all right there?
18?
No.
9.
9. Okay, so the whole thing's 9. So let's just check it. If I took 9 and I multiplied by 2/3, would I get the 6? You want to check it? We could do it out. We could get multiply it all out. I could show you how to do that, or you can do it on your calculator. I don't mind. What is 9 times 2/3?
Oh, wait,
6. Okay. What about 9 times 1/3? We said that this part was 1/3. By the way, when you do something by 1/3, it's like dividing it by 3.
3.
So it should be 3. All right. Okay. This is like dividing by 3 and then multiplying by 2 again. So that would have been 3 times 2, which is 6. Okay. All right. So this centroid, the centroid always splits the median into a 2/3, 1/3 ratio. Okay.
That's not hard.
All right, well, we're going to do some examples a little bit for your homework, okay? So it doesn't matter where I go, it's still going to be a 2/3, 1/3. On this particular one, which part is the 2/3?
BP?
Yes, BP. And then that means this part down here is the 1/3. You can probably tell it's bigger, right? The top part's longer than the bottom part, but it's always the one from the vertex down. All right, so let's do another one. If I do the next one, what part is the 2/3 and what part's the 1/3? CP is
2/3.
the 2/3, and the 1/3 is the rest. Okay? All right. You might want to give yourself some kind of picture in your postulate book. I would even think that it would be appropriate for, with your centroid that you've drawn in there, I would even think it appropriate to put something like 2/3, that's a terrible 2/3, 2/3 there and 1/3 there. You could put it on the same picture you had above if you wanted. Sometimes for me, if I have too much stuff on one picture, I can't get it all distinguished. But if you want to do it all on one, that's not a problem either. we drew that. Now, a really cool thing.
I was barely pushing.
A really cool thing about the centroid of a triangle is if you took a piece of cardboard, and you found the centroid, it would be the place where it would balance. It would be its center of gravity, all right?
It didn't work.
So you have, as long as it's uniform in density, and in the sense that it can't be heavy on one end compared to the other. A piece of cardboard, you could balance it on that point. Okay, really cool thing about the centroid, which would help if you're making kites, if you're making hang glider type of things. You'd want to know where the balancing points were. Okay. All right, you have this thing in your notes. You have a triangle to glue. See if you can figure out which of the two triangles is has the centroid or has all the medians, based on the picture that's there. It should have some kind of picture. It's got a B on the back, yes.
Ha. So I did guess right at the beginning.
It's going to have some medians here.
Do we go ahead and glue it?
Yes. Your centroid is in the center. It's created by, how do we find the centroid? What are being used to create that centroid?
Not angle bisectors.
Not angle bisectors, not perpendicular bisectors either. What are those lines called?
Segments.
What do I call this one that goes from the vertex to the center of the opposite side? What's the name of that one?
Median.
The medians. It is created by the medians. That's correct. And then your important fact is the same as your theorem. The centroid of a triangle is located 2/3 of the distance from each
Median.
side.
Wait. What?
No, maybe it's a vertex?
It's
vertex. Each vertex
To the
midpoint.
opposite.
midpoint of the opposite side. We got opposite and midpoint. Yep.
Of the opposite.
I'm going to abbreviate my midpoint because I can't get it to fit very well.
I'm going to change.
Opposite side. Okay. By you having all your centers of triangles in one spot as opposed to having to flip through your postula book, that it makes it easy to do your homework. But I want you to be cautious because you will not have them all in one place on your test. And when you take your test, you're going to have a section in the back that's all your postulates and all your proofs, which is going to include some pictures. You're going to be practicing in this next lesson some pictures, and you're going to have to look at a picture and know if it's the centroid, know if it's the incenter, know if it's the circumcenter or the incenter. So you're going to need to know these pictures, but you won't have this note sheet in front of you when you take your test. And you won't have your postula book either because that's the section you're not supposed to use your postula book. So make sure you get them in your head. So as you're doing these on your homework, I would suggest you do if it's asking you a question and you don't know if it's the incenter, you don't know if it's the circumcenter, you don't know if it's the orthocenter, you try to make an educated guess, then you go to your postula book and look if you're correct. That instead of just like blindly looking at it and not even trying to get it in your head. So try to guess, oh, I think it's this because of these different facts. Then go to your postula book to see if you're right.
On the test, the main reason why I get most of them is because I read the definitions, like for the side angle, side kind of thing.
Yes.
It literally
It already says
you, like,
that. Yes.
Yeah.
Yes. And
That's
so
why I
that
get
will
most
probably
of
get for
them.
your postula books. But these picture ones, it might not. You'll have to know stuff about them. So make sure you know those. All right. We're gonna do some homework now. Questions, at least some examples from your homework. This is from 5.3, numbers 1 through 9 odd. We're going to do together. All right, number 1. ask you to find ds, and I'm going to highlight it in yellow because yellow will tell me that that's what I'm looking for. I'm looking for ds, and it tells me that qs is 6.6. And the instructions at the top say, for each figure shows a triangle with one or more of its medians. So you know that those lines in there that are being drawn are medians. So if it's a median, how are we going to find what ds equals?
6.6 divided by 2 is going to be 3.3.
Ooh, so I should have drawn it like this. That's 6.6, correct?
Correct.
So then that part is half, right?
Correct.
Which is 3.3. All right. Questions? Find x. We're going to go number 3. It tells us that qy is 2x and qz is x plus 4. How are we going to make an equation out of that?
Add them together.
And equal what?
Equals 2x.
Well, why would we add them together now?
Well, because that's going to be the whole distance.
Do you know the how much the whole distance equals?
No.
Okay, so what? Do you have any ideas?
They're equal.
They're equal to each other. That's correct.
Oh,
We're going to go
yeah,
2x equals x plus 4. If you knew how much the whole thing was, Naraya, then yes, you could do that. All right.
Four.
I got x equals 4. I did too.
So then the whole thing would be 8.
Yes, if then yes. So the whole thing would be, actually this part would be 8 and that part would be 8, so it would be 16 would be the whole thing.
What would be 8? What would be 8?
Okay, so is that what you're asking me? What's your question? Maybe I didn't understand.
The whole line.
The whole line,
Y, Z.
y, z, we're from here to here.
Yeah.
If we needed to know it, we would be able to plug this 4 into there, right? And so that part would be, this piece from here to here would be 8.
Yeah.
And that would be 8.
So
So the whole piece would be 16.
Okay.
Okay? All right. And yes. Let's go to number 5. Any more questions on, wait, I should ask. Any more questions on 3? All right.
I wanted to write this down so I would have it just in case.
Yes. Please do. So I think you were doing number 2.
Well, I
Oh, you
had
did.
most of it, but you know.
I'm teasing you. All right. WF, the whole thing, is what we're looking for. And they tell us that that little piece right there is 3.6. What is the relationship? I should make it color, different color, like that is the 3.6. What is the relationship between the whole and the piece that we know
The piece that we know is 2/3.
of the whole, correct?
Correct. So we would multiply that times 2/3.
No.
No.
1/3.
I have to do it this way. I'm going to say
Right.
2/3 of what we're looking for is 3.6. That's what I have to do. 2/3 of what we're looking for, 2/3 of that whole thing is what they gave us as the 3.6.
So technically just...
So technically it would be...
What do I do when I have a fraction in front? How do I get a fraction away from the variable?
Can you just like... so the X...
Instead of dividing by 2/3,
You where you like flip it...
Yes.
Do the
multiply by the...
or
It is an inverse. It's a multiplicative inverse, but it's called the reciprocal. So we're
Reciprocal.
going to go 3 over 2. Good. And 3 over 2. So x is going to be 3.6 times...
5.4.
Is there
3 over 2 is 5.4. That's what I heard.
I just did 3.6 open parentheses 3 divided 2
Do you
close parentheses.
know how to use the calculator? Your fraction button on your calculator, Amy?
Oh, I don't use the
I'm going to talk about when do we leave it as a fraction and when do we keep it as a decimal, okay? Because on your calculators, you could turn that into, what did you say, 25 over what?
27 over 5.
Over 5, okay. So, if the original problem has a decimal in it, then you
It's a decimal.
can give me a decimal.
Okay.
If the original problem does not have a decimal, then you do not give me a decimal. All right? So, because you have fraction buttons that can turn those things into, all right, into fractions, yes. All right. Let's go do number 7. Number 7 asks us to find x. ZR, which is the whole thing, they're telling us the whole thing is 5x minus 5. And I'm going to change colors. Then they're telling us that ER, which is this little portion right there, is x plus 3.
Wait.
What's the relationship?
X plus 3 plus 2/3 equals 5 minus x? No.
Is that the 2/3 portion or the 1/3 portion?
It's the 1/3 portion.
So 1/3 of what equals what?
1/3 of 5x minus 5 equals x plus 3.
1/3 of the whole equals the little piece. Okay? So you were right. 1/3 of the whole, which is 5x minus 5, equals the little piece. That's x plus 3. I'm going to move this away. We're going to have fractions. Do you guys like fractions?
No.
Before we go anywhere, let's get rid of the fractions. How do we do that?
Multiply by the reciprocal.
Yeah, we could. Yes, we could. And what is the reciprocal of 1/3? 3. And actually, Heidi, multiplying by the reciprocal in this case would work because there's a 1 here, and the reciprocal would make 3 over 1, and then they cancel. But if I had a 2/3 and I multiplied by the reciprocal 3 over 2, I'd still have the fraction in the bottom. Okay, so it's not when you're trying to get rid of the fraction, multiplying by the reciprocal won't help. But what will help is multiplying everything by the denominator. So if I want to get rid of the denominator, I don't want a denominator, I'm going to multiply by 3 on this side of that whole side, and 3 on this side also. I have to do it on both sides of the equation, or I'm ruining the equation. Okay? The nice thing about multiplying by 3 on this side, that goes away, and I'm left with just 5x minus 5.
Oh, yeah.
And on the other side, I do the distributive property. I have 3x plus 9. I'll let you guys solve that. And I'll do the same, and we'll work together. Amy, are you with me on that multiplying by 3 on both sides?
Yeah, but I just wanted to write it out longer.
Yeah. Please write it out longer.
It's going to confuse
Yes,
me.
please do. Just want to make sure you're with me. I got x equals 7.
I did as well.
All right, x, and it said to find x, so we're done. If you were doing this by yourself, could you now make the original equation?
Huh?
The hard part for this one was not solving this equation. It was getting this red one at the very beginning. That was the hard part of this. Is that something you could do by yourself?
See?
Let's practice another one and see if it helps.
Can you say that again?
So the hard part of this particular problem was getting this original equation. 1/3 of the whole equals that little piece. Solving it afterwards is not the difficult part. Let's try number 9 and see if that helps. Let's see. It says that JU, which is this whole piece,
Number where?
number 9,
Oh.
okay, is 8x minus 5.
Wait,
and
is this
then
pretty much the same equation that we just did?
Pretty much.
Set up?
du, it said is 2x.
Oh, 1/3.
Is it one? It is 1/3. 1/3 of what equals what?
1/3
Of 8. Wait, wouldn't it be like
Uh-huh.
8x minus 5?
Yes, it will.
equals
1/3 of the
2x?
whole equals. I'm gonna have to do
2x.
something about that because I
Oh,
can't.
wait, but.
Wait, wouldn't it?
Go ahead, Heidi.
only
J-
multiply. Oh, sorry. Go ahead.
No, you can go ahead, Mariah.
What I'm confused about is why we only multiply the 1/3 by 3 when over there we did the distributive property.
Oh, okay. All right. Because up at the top.
Yes.
Why did we only do the 1/3 right here? And no, multiplying the 3 on both sides.
Yeah.
Why did we canceled it on that side and we distributed it in there?
Yes.
Okay. So I'm gonna
I mean, I know I've done this before. It's just been a long time.
So I understand, and that's a great question. So if I did 3 times 4 times 5, all right? Which do I multiply first? The 3 and the 4 and the 5? What do I multiply first?
Technically, couldn't you do whatever you want?
You can do whatever you want, yes, okay? Because there are 3 of them. The associative property says that I can multiply those in any order, and commutative too, okay? So up here, Naraya, on this is really messy up there, I apologize. Let's get a different color of my highlighter so that I can maybe, there we go. I'm trying to figure it, okay. So right on this side, there are only 2 things to multiply. On this side, when I had the 3 and the 1/3 and the 5x minus 5, I had 3 things to multiply. So I chose to multiply those 2 first, because they would cancel. If I multiplied the 1/3 in, that would have been fractions all over the place.
Yeah, I tried it.
Yeah. So I wanted to get rid of it. So when I had 1, 2, 3 things to multiply, I chose to multiply the first 2 first, because just like Amy said, you could do it in any order I wanted. Then I could get rid of my fractions to do it the next way. Just like when I was down here, and I did the 3 times the 4 times the 5. Sometimes before I multiply, I pick which ones, I know that's 20, and 20 times 3 is so much easier to multiply than doing 15 times 4, because I don't know what 15 times 4 is.
5. Oh, wait.
Because I can do it in order. Or I could do 12 times 5, and so I might not know what 12 times 5 is, but I do know what 20 times 3 is, so I can do it in any order I want. I'll get the same answer.
I guess what I'm not understanding is how come we only multiplied the 1/3 and not the other stuff in the parentheses too. I mean,
oh, this right here, when we multiplied right here, became 1. That became 1.
I know, but with the 3 on the other side, we multiplied both the x and the 3 by 3.
So, because to multiply something that's in parentheses, you have to do the distributive property. We would have, over here, the part that I've just circled right here, that became 1. And then I can do 1 times 5x and 1 times 5 became that there. So I did, in a sense, do the distributive property on that side. Okay? All right. Fantastic questions.
Okay. Well, you were talking about that. But this is confusing me.
Okay, let's do this. Let's finish 9
yeah.
and then I'll do that.
Okay.
Sound good?
Oh yeah, we're still on that.
Yeah. Go ahead, Heidi.
Why have we always in 1/3?
Good question. Just because the problem just turned out to be, if they would have told you that instead of du but ju right here was 2x, we would have put the 2x over there, and we would have said 2/3 of the 8x. We would have put the 2/3 there. Just so happens to be these 2 problems happen to have the smaller side as it's.
Okay.
Okay?
But we're going to do the 1/3, or the 3 thing with the, wait, would you just put this
Yes.
in
I'm going to multiply 3 here, and that's on that whole side, and 3 on this whole side.
So you just do 3 times 2.
Yes.
Okay.
So it'll be 6x, right?
Yeah.
And then to get rid of the negative, you can add the 5 over the other side and subtract the 6.
So that's going to cancel. That's going to become 8x minus. I'm going to move the 5 over here by adding, and I'm going to move the 6x over here by subtracting. So I'll have 2x equals 5. I'm going to divide by 2, and I will get x equals 5/2. Notice my original did not have decimals, so I will not have decimals here. I will leave that 5/2, but I'm not finished because I'm asked to find JD. JD is this section right there, which I need to. This is getting really messy. I'm going to take some time to get some room here, just a second. So if we find this piece right here, we can multiply by 2 to get that piece. So if I plug in the x into the 2x, that's how long that is, we'll get 5/2 times 2. That will become 5. And that piece is now double that, so it's 10. JD is 10. Okay, we're going to do altitudes of triangles now. And you guys have opened up your postulate books. We're going to draw some pictures for this. She said altitude of a triangle should be right after. I've been going pretty close to an order. So if you keep going back. Oh, you have things in different. Oh, yes. Okay.
I like, if it's not a postulate theorem, it's in my extra terms.
Right, that makes sense. So an altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. So here is an example. I actually would like to do something for you. I'm going to take out some of these so we can see what they'd look like, just one of them. I'm going to take out these. So you can see just one of them, all right? I did wipe out some of that triangle too. But I want you to notice that it's perpendicular. It comes down from the vertex. It's perpendicular. The last time we did a perpendicular, it was a perpendicular bisector, okay? And it didn't necessarily, it might have even gone, if it was a bisector, it might have come here, and it did not necessarily even go through the vertex at all. This one will go through the vertex, and it will not necessarily be a bisector, but it will come perpendicular to the opposite side.
So that's all we need to draw.
Yes.
We don't need to do.
We're going to do 3 of them. Yeah, you will do 3 of them in a moment because it'll meet at a certain spot. It will be
So we do
concurrent
need to
also.
do the extra line.
Yeah. If you want to make that into 2, it doesn't matter. I just wanted you to see what it looked like with just one of them at first.
Okay.
They're all 3 going to meet at one place. They're going to be concurrent. They're going to meet at one point. And you have already drawn that in there, and it's called the orthocenter. Yes. And you have a definition right underneath, very likely, the orthocenter of a triangle. It tells you it's the point of concurrency of the 3 altitudes of a triangle. Okay? So you can just draw your little arrow there if you'd like, from there on over. Let's talk about that orthocenter. There's a theorem that goes with it, which can be either on the other page or next to it. Do you have an orthocenter theorem?
Yeah.
Oh, it's going to be in my theorem section.
Oh, whoa. You guys have different sections. Okay, all right. Your orthocenter theorem, actually, I think it's quite boring. It says that the orthocenter theorem says the line that contains the 3 altitudes are concurrent at the orthocenter. It doesn't say that they're like 2/3 of the length. It doesn't say that, and it just says that it meets at the orthocenter. Okay, so there isn't any mathematical relationship with that point with the rest. Okay.
So it's the same drawing also?
Yes.
Right, the other stuff is all.
You can just point up to it unless it's on a different page. Okay.
Oh gosh, give me a second. I'm going to have to draw 3 of these.
All right, you had a chance to draw it. We're going to draw these. There will not be any mathematical problems on your homework for these. They will be constructions. All right? So I will be showing you how to do the constructions on your homework.
Wait, why is there a G there?
That's the point of concurrency. You can put the G there if you'd like. It will be okay if you like to use an A if you want to.
No, wait,
All right.
Wait, I thought there was an orthocenter.
It's called the orthocenter. It is. All right, so I have gotten 3 triangles here. I have
Okay.
an acute triangle. The orthocenter is where?
Where
Near the
dot
top.
is.
Where they connect right there, correct?
Yep.
It's on the inside. Let's do the next one. I have an obtuse triangle right here. I'm doing them in color because sometimes it's hard to tell which one is the original. And this time,
It's gonna be outside.
it's outside.
But it doesn't show us where.
It's out here.
Well, isn't it? Yeah, I was going to say.
Oh.
How did they get that, though? They got that by extending out these sides, and here's the perpendicular. They extended out these sides, and then there's the perpendicular.
Oh,
The-
that is triangle.
That yellow part's the triangle up there.
Oh.
The yellow part is the original triangle, because I think it was hard for you to tell what the original triangle
Yes, it
was.
was.
So I put it in color. Yeah, because sometimes this 3D thing starts happening and you don't know where your eyes are supposed to go.
Yeah.
So that's the original. They extended out this side and then drew the perpendicular, and it kept going. They extended out this side and then they drew the perpendicular here,
Gotcha.
and it kept going. And then this perpendicular, which they drew this direction, but it had to come back this direction. Their orthocenter is way out there. So your obtuse triangles, your orthocenter is going to be on the outside.
Well, but why isn't it the dot right there in the center of the thingy with the lines through it?
Because that is the point of the triangle.
Yes, because this maybe I should use some different colors.
Does
Just a
that
second.
make
Let's go back.
sense now?
It does make sense to you?
Mhm.
Okay, let's go forward then. Outside. Come on. All right. Now, this is a right triangle. Let me tell you where the original triangle is. It's right here. All right. When they drew the first altitude, it was right there. But this, from this vertex, going a perpendicular, it comes right on top of itself. When you want to do a perpendicular, it comes right on top of itself, and this one goes right on top of itself. So where's the orthocenter for a right triangle?
What corner?
On the triangle. It actually is at the right angle. It's at the right angle. I should do it like that.
Sweet.
Okay. So your orthocenter for a right triangle is at the right angle.
That's nice.
Mm-hmm.
Okay. All right.
It's like moving popcorn in a movie.
All right. You have this to fill out. We got your orthocenter, your last one to put on there. You have your altitudes. It should look something like,
Hey, stay. Go on.
it came straight down on this one. I might have done something really bad. Just a second. I think I gave myself a right angle. I don't want to give myself a right angle. Okay, so my orthocenter, we're going to come straight down right there. We're going to come like that. That looks like a 90 degree. And we're going to come like that. And that looks like a 90 degree. So, oh my goodness. Like that. And that's my right. There's my orthocenter. What did I draw? What were all 3 of those things called?
The altitude.
Altitudes.
Wait. That's not altitude.
I love it. Altitudes. Hey, that's an altitude.
No.
All right. This interesting fact is just your theorem. The lines that contain the 3
Altitudes?
altitudes are something at the orthocenter.
Concurrent.
Concurrent.
Oh, I never missed that. Let's move that over just a bit.
Does that fit?
Anything? I had to move it over.
I couldn't squish mine. All right. We covered a lot in this lesson. We covered the points of we covered some stuff. Which of the points of concurrency will always be inside the triangle?
centroid?
The centroid. If you want to put that on your little yellow sheet, you're welcome to do that. You're welcome. We covered that. We have now just finished that orange sheet, yellow sheet that you had. And we answered some questions. What lines meet to form the centroid?
Wait,
The
it's always-
medians.
Very good. You somehow need to get that in your head without this picture. So as you're doing your homework, make sure you're trying to remember, oh yeah, medians goes with centroid. Medians go with centroid. All right, so if the centroids are for the median, what is the orthocenter? What lines meet for the orthocenter?
Altitude.
Altitudes, you got that on there. What lines meet for the in-center?
Bisector.
Angle bisector.
What, yeah, there's two kind of
Angle-
bisectors. There's
angle
angle and there's perpendicular.
bisectors.
Okay, so angle bisectors. And then what form this circumcenter? The perpendicular bisector. So somehow you can get those in your mind. All right. We will be doing constructions. Right now, we'll do those together, 11 through 22 odd together, so you'll learn how to make draw your altitudes and draw your medians with doing constructions. They will not be videoed, okay? And I'm going to say goodbye.